So on the previous screen, or previous slide, we came up with this relationship that the acceleration is mg sine theta over m plus I over r squared. You notice that dimensionally this works out. We've got mass on top, and then I over r squared is mass. We have mass on the bottom. Going back and remembering, we had a force of friction up the incline. We had a normal force, and then gravity pointed down, and we drew in an mg sine theta force going down the incline. And so what we'd like to do is go back and look at what that minimum friction is in order for it to roll as opposed to slipping. So the force of friction is given by mu Fn, which looks like mu mg cosine theta. And the other piece going back, remember we said that I alpha is equal to R cross F, which gave us that alpha is equal to R force of friction divided by I angular acceleration is A over R. And so I can take this acceleration here, plug it in, and we can come up with a value for the force of friction. So I'm going to rewrite this slightly as R squared force of friction divided by I is equal to A, which is equal to mg sine theta over m plus I over r squared. I can solve for force of friction is equal to I mg sine theta over r squared times m plus I over r squared. And then with a little bit of effort, I can write this as follows. I can take and say that mg sine theta over, and I'm going to bring this in here and say m r squared over I plus 1, because I have an r squared here, I have an I here, is equal to force of friction, which is mu mg cosine theta. Force of friction is mu mg cosine theta. So with a little bit up ahead already. So with a little bit of effort, this mg and that mg will cancel out, and I'm left with tangent theta over 1 plus m r squared over I is equal to mu. And if you stop and plug in some values that we're familiar with, if I say that I of a hoop is mr squared, plugging that a number into here, I get mu is equal to 1/2 tangent theta. And remember that for a block on an incline, we said that mu static static has to be greater than or equal to tangent greater than or equal to tangent of theta. So in order for it to roll, it turns out using a hoop, it turns out that you can have basically half of the static friction and it will still roll, as opposed to this where I have a block on an incline. This result here, although I don't like to memorize results, this result here applies for all items. So for example, if I were to do a ball on ramp, I could rewrite this as tangent theta over 1 plus mr squared over a ball is 2/5. Mr squared is equal to this minimum mu. So I should get 1 plus, clean that up. 1 plus, so this would look like tangent theta over 1 plus 5/2, which would look like 7/10 tangent theta is equal to mu. Thank you very much.